Start with the foundation of propositional logic, the proposition. A proposition is simply a declarative sentence that is either true or false but not both. For example, Chennai is the capital of Tamil Nadu is a proposition because it can be classified as true. Similarly, 2 plus 7 equals 10 is a proposition but it is false. However, sentences like do you speak English, or commands such as obey orders are not propositions because they are not strictly true or false. In logic, we use symbols like P, Q, and R to represent propositions. True propositions are denoted by T and false ones by F. This clear distinction helps us analyze logical statements systematically. Now let's explore how we can build more complex statements using logical connectives. The 5 basic connectives are and conjunction symbolized as or, disjunction symbolized as not, negation symbolized as if, and conditional symbolized as right arrow, and if and only if biconditional symbolized as left right arrow. For instance, if P is it is snowing and Q is I am cold, then P and Q means both are true. If either P or Q is true, P or Q is true. Negation simply flips the truth value. Conditional statements express if P then Q, and biconditional means both must have the same truth value. These connectives allow us to construct and analyze compound statements. Systematically determine the truth of compound statements, we use truth tables. A truth table lists all possible truth values for the component propositions and shows the resulting value for the compound statement. For example, for the statement P and Q, the result is true only when both P and Q are true. For P or Q, the result is false only when both are false. Truth tables are essential tools in logic, helping us visualize and verify the validity of statements, including more complex forms like conditionals and biconditionals. By filling out these tables, we can easily see when a statement is always true, tautology, always false, contradiction, or sometimes true, contingency. Propositional logic. Statements can be rewritten in standard formats called normal forms. The disjunctive normal form DNF expresses statements as a sum of elementary products, while the conjunctive normal form CNF expresses them as a product of elementary sums. These forms help in simplifying and analyzing logical expressions. Additionally, there are important equivalence laws such as De Morgan's laws, which relate conjunctions and disjunctions through negation. For example, the negation of P and Q is equivalent to not P or not Q. Understanding these normal forms and equivalences is crucial for logical reasoning, proof construction, and problem solving in mathematics and computer science. Beyond basic propositions, logic extends to predicates and quantifiers, allowing us to express statements about objects and their properties. Predicate logic introduces variables and quantifiers like for all and there exists. For example, for all x if x is healthy, then can work is written as xhx right arrow wx. Logical inference rules such as modus ponens and hypothetical syllogism help us derive conclusions from premises. Predicate logic is foundational in mathematics, computer science, and philosophy, enabling precise reasoning about sets, functions, and relationships. Mastering these concepts equips you to tackle more advanced logical arguments and proofs.